Hello everyone. In today's lecture, we'll cover vector part. Again, vector is very important in physics because we'll see from chapter 1, from straight line, application of vector. Without vector, you cannot imagine physics. In every chapter, vector will be required. That's why we have to study basic of vector in beginning. Although this is mathematics topic, we'll study vector in detail in mathematics. But here again, we'll study vector. Okay. So this vector is basic here only. So basic part. So let me define here scalar and vector. Okay. So first I will define scalar. So scalar, this is physical quantities. What is physical quantities? Physical quantity term is coming here. Let me define first, then I will explain. Physical quantities, physical quantity. In shortcut, I will write PQ only. Okay. So physical quantities which have magnitude only, but no specific direction, no specific direction, known as scalar. Okay, so physical quantities means any quantity in this world which is measurable, which we can measure, that is known as physical quantity. Like if I'm saying area of this plane, area of this surface, we can measure. Okay, I can say what is power of this bulb. I can say what is dimension of this board. Okay, what is mass of a certain quantity. Okay, so anything which we can measure, that is physical quantity. So physical quantity which has only magnitude, no direction, means magnitude is enough, no direction is required, so that quantity is known as scalar quantity. Here magnitude means it will have numerical value numerical value plus unit, numerical value plus unit. For example, I am saying that mass equal to, let's take 10 kg. So this 10 is numerical value, and this kg is unit. So there will be numerical value and unit. Like length, say certain length I am saying 20 meter. So this is again numerical value. This is unit. Okay. So this is how we can numerical value and unit. Okay, so any quantities which has numerical value only, numerical value plus unit, means magnitude only, known as scalar quantities. Okay, so here we can say it will follow simple algebra. Okay, it follows simple algebra. It follows simple algebra. It does not follow vector algebra. There are two types of algebra also. Simple algebra means we are doing any addition, subtraction. Still now we are doing all algebra. That is simple algebra only. Okay. So example of this one is like distance, speed, speed, then current, mass, time. Okay, so many. Okay, like density. So there are so many examples. Okay, which has only magnitude, no direction. Okay, it follows simple algebra. Okay, physical quantity having only magnitude, no direction, known as scalar. Magnitude means numerical value and unit, and it follows simple algebra. Okay, so next one is vector. This is first one, and second one is vector. So again, vector we can define physical quantities, physical quantity which has physical quantity which has magnitude as well as specific direction, known as vector, known as vector. And very important conclusion, it will follow it follows vector algebra, it follows vector algebra. Okay, so example for this one is, let's take example. This is displacement, then velocity, acceleration, force, momentum, momentum, torque, torque, electric field, magnetic field, so many. Okay, we will see later on. Okay, so many vector quantity means wherever magnitude as well as direction both are required, that quantity as vector quantity, only magnitude required, that is scalar. Okay, it will follow vector algebra. Means here we cannot say simply 2 plus 2 equal to 4 or 3 plus 5 equal to 8. Okay, it will be different. It may be when angle will be 0, both will be in same direction, but here always 2 plus 3 5, here not always 2 plus 3 5. Okay, it will be different. So here, this is vector. Now example. Okay, so we have to represent now vector. Okay, so representation of vector, how a vector is represented. Okay, so whenever you want to represent vector, so vector means you have to represent uh, arrow like this. This is known as head and this is known as tail. This arrow will represent direction. So here we can say whatever is this length. Okay, we can say in general this length will represent here, this length will represent magnitude of vector, and tail 2 we can write here for direction. Tail to head is direction. That means this one is tail from where vector is originating. So tail to head is direction of vector, and length of this vector is magnitude of the vector. Okay, so two things, magnitude means length and direction means tail to head, and generally it is represented by just an arrow. So this is how mathematically we can represent it. Like if I'm saying, let's say vector A, so I can write here vector A means simply I will represent like this. Okay, so vector A, here if I'm saying magnitude of vector A, magnitude magnitude of vector A, so it will be represented like magnitude. This mod is magnitude and this is simply A. So simply A means magnitude of vector. Okay, and this one is same as, but we don't write like this. Okay, although this is same. So this one mod vector A is nothing but A only, and this one is vector form. Okay, so let's say there is any vector F. Okay, any vector V, any vector A, so we can write like this velocity vector. Similarly, if I want to write velocity vector, so I can write V. Okay, if I'm writing acceleration vector, so we can write here A. Okay, so any vector are there, simply we will put one arrow. This arrow represent that quantity is vector quantity. That doesn't mean this is right side only, that mean this is vector quantity. Okay, it's not like this is right side so direction will be right side. No, this is representing only direction. Okay, so any vector, let's say vector F, so we will write here F and we will put one arrow over there. Okay, so that will be a vector quantity. Okay, so this is how vector is represented. Now we will see properties of vector. Properties of vector. Properties of vector. So first property is first property is if a vector is if a vector is parallelly shifted, then vector remains remains or vector doesn't change. Okay, that means if there is, let's say, a vector A like this. So what is the meaning of vector? It will have magnitude and direction. So here if I'm writing with same magnitude vector A like this, we can write here like this, here like this. So in every cases, let's say I'm not changing magnitude and I'm not changing direction also. This one, all are same. That means magnitude I'm not changing, direction I'm not changing. That means vector I'm not changing. So what is conclusion here? Vector is parallelly shifted, vector will not change. Okay. So if vector is parallelly shifted, the vector remains same. Okay. Vector remains same. Vector will not change. Okay. So here, if I'm saying there is a force, okay, let's say there is a body, okay, let's say 2 Newton force you are applying on it. So we can write here like this, okay, parallelly shifted 2 Newton, vector will not change. Okay, so here we can put here any means we can parallelly shift the vector 2 Newton, 2 Newton. Okay, so here it will not change. Okay, point of application will change, but vector means magnitude and direction. Magnitude same, direction same, so vector will not change. Okay, so this is properties number one. Second property is second property is second property is if a vector is let's say this is a vector and you are rotating this vector, okay, rotated by let's say theta angle. So I'm saying this is vector B. This is not vector A. Although rotating means magnitude I am keeping same, but here this is a different angle. So this is a vector which has this magnitude and this direction. This is a vector which has same magnitude, but let's say this vector B mod equal to vector A mod. Magnitude of both is same, but direction is not same. So we cannot say both vector is same. So we can conclude here that if a vector is rotated by any angle by any angle other than integral multiplication integral multiplication of 360, other than integral multiplication of 360, then vector changes. That means if we will rotate it by 360, this will coincide with vector A. So magnitude of A and B both are same, coincide with vector A, that means it will be in same direction. So vector B and vector A will be in same direction and same magnitude, so vector will be same. So other than 360, integral multiplication of 360, other than integral multiplication of 360, that means you rotate it by any angle other than 360. So direction will be different. Although magnitude same, but direction will be different. So vector will change. Okay, so vector changes. Third one, like if I'm saying example, let's take here 5 meter per second. So here 5 meter per second. So this is let's say B, this is let's say A. So here A is not equal to B. Okay, because direction here, direction here. So both velocity representing here different. Okay, here. So both are different velocity. This one is 5 meter per second this direction, 5 meter per second this direction. So both are different. Third one, condition for two vector vectors to be same. In which condition two vector will be similar vector, same vector? So here two vector similar means magnitude of both vectors should be same. Second, direction of both vectors should be same. This is not sufficient. We have to also confirm that both vector represent same physical quantities. Okay, so we can write here uh, both vector both vector must have same magnitude and also we can say same direction also. This is not enough. Direction and magnitude both vectors should represent must represent must represent same physical quantity. This PQ means physical quantities. Okay, so three things: same magnitude, same direction, and should represent same physical quantities. Clear? Then we will say that both vectors are same. Like if I am saying this is 5 Newton, this is also 5 Newton. Let's say this one is B, this is vector A. So here we can say A equal to B because same magnitude 5 Newton means same. But here if I'm saying, okay, here if I'm saying this is, let's take 5 Newton, this is, let's take 5 meter per second. So this is velocity, this is force. Although magnitude same, direction same, but both are representing different physical quantities. So if this is vector A, this is vector B, so we cannot say this is, okay, this will be different. Why? Because this is force Newton, this is velocity because meter per second. So both are representing different physical quantity. And third one, which is last one, third one is the fourth one. This is to find out to find out angle between two vector two vector to find out angle between two vector. Condition here, always connect tail to tail and then you measure angle between them. This is one whole line. Okay, to find out angle between two vector, always join tail to tail, then measure angle between them, then measure angle between. Okay, so this is how. Let's say there is a vector A, there is a vector B. So here angle is theta. Now tail of vector A is this one, tail of vector B is this one. So we can say this theta is angle between A and. Clear? So this is how we can measure. Okay, so we will take one question based on it to find out angle between vector A and B. Okay, so this is how we can understand about scalar and vector and properties of vector. Okay, so here I will take one example. If I'm saying that, let's take this is a vector A, this is a vector B, and I'm giving here angle 30. So find angle between vector A and vector B. Okay, so here what you do, this is not tail to tail joint. Head of vector A coinciding tail of vector B. So here we will modify first. So modify means I will shift, this is vector B, so I will shift vector A parallelly. If you are shifting vector A parallelly, it will not change. So I am starting vector A from tail of vector B. Okay, so here this angle is given how much, 30 degree. So this angle will be how much, 150 degree. So this 150 is angle between A and, okay. Similarly, one more question. Uh, if I'm saying that this is, let's take 30, let's take this is 50, 30, 50, 80. So let's take 120. Okay. So 80. Okay. So this is, let's say I'm saying this is vector A, this is vector B, and this is vector C. So what is angle between? Find angle between vector A and B, vector B and C, vector C and D. Okay. So how will you find out? We will remember concept, always trying tail to tail. So this is vector A, this is vector B. So I will draw vector A here. Okay, so this is vector A. Now vector A and vector B is coinciding. So this is coinciding point. So we can measure this angle. This angle is 180 minus 50, 130. So angle between vector A and vector B is how much? 130 degree. Similarly, this is vector B, this is vector C. So I will extend this vector B here. This is vector B. Okay. So what is, this is 110. So what is this angle? This is 70 degree. Okay. 70 degree. 180 minus 110, 70. So B and C will be 70 degree. Similarly, this is C. So we can extend C here. This is C. So between C and between angle is 180 minus 30, that is 150. So we can write this is 1. So this is how we will find out angle between vector A and vector B. So any vector, if there are any two vector, to find out angle between vector, always we will connect tail to tail. Okay, tail to tail of vector. Either you shift A or B. Okay, it will not affect. Always tail to tail must join. Okay, so after connecting tail to tail, find out angle between A and B. So we can get answer. Okay, so in this is today's lecture. In next lecture, uh, next I think 2 3 more lecture, half an hour, it will take 1.5 hour more. Okay, so we'll complete in that much. Okay, thank you so much.